Now let us understand the bitwise operators here. So bitwise operators which performs the operation on bits of an operand here. Okay. So there are different type of bitwise operators like bitwise AND, bitwise inclusive OR, bitwise exclusive OR, then bitwise negation, then left shift and right shift, bitwise right shift. Okay. Now let us understand the bitwise AND, bitwise inclusive OR, bitwise exclusive OR, then the bitwise negation. Later we'll understand the left shift and right shift which will perform on the operands here. Okay, let us consider the table for these bitwise operators here. Okay, this table shows the operation of bitwise AND, bitwise OR. So this is also called as a bitwise inclusive OR, then bitwise exclusive OR operation here. So if I consider the inputs R1 and R2, and the inputs are like this, R1 and R2 are true, then bitwise AND will become as a true, then bitwise OR operation will become as a true, and bitwise exclusive OR will become as a false here. Then true and false, it will become as a false, true, then true for the exclusive OR here. Then false and true, it will become as a false, true, true. Then false, false, if two inputs are false, then the bitwise AND will become as a false, and bitwise inclusive OR will become as a false, then bitwise exclusive will become as a false here. Now let us understand the difference between the single AND symbol, then double AND symbol here. So the single AND symbol which indicates the bitwise AND operation. So this is the bitwise AND operation. For example, if I perform x is equal to a and b, so this will perform the logical AND between the value of a and b here. Getting my point? This is the bitwise AND, and this is a double AND symbol which indicates the logical AND operation here. As we have used in the previous example, the usage of the logical AND operation. Suppose if the AND operation is used with the variable which is used in the scanf statement. For example, scanf %d ampersand a and symbol a. So that time this indicates the address of the a here. So this value will be read from the keyboard and it will store the address of the a here. Okay, please be clear with this single AND operation and this double AND operation and the AND operation which is used with the variable a here. Okay, now we'll understand the left shift and the right shift. Okay, so left shift, which is indicated by the left less than double less than symbol, then a right shift double greater than symbol here. So what these shift operation performs here, it will shift the bits towards left, and right shift, it will shift the bits towards the right here. Now let us consider an example, that is, so I'll consider a is equal to 10 here. Okay, now how we are going to find out? This is in decimal, this is in decimal. Okay, now how we are going to represent the 10 in binary? So as these bitwise operators which performs the operation on the bits of a number here. Okay, now we need to consider this in binary here. So binary, that is 1 0 1 0. So this is the binary representation of the 10 here. Okay, this is in decimal, this is in binary. Getting my point? If suppose I have performed the left shift, okay, so how it will perform here? Suppose I'll consider x is equal to a left shift by 2 here. I am performing the left shift 2 times. The A value is 10, then I am performing the left shift by 2 times here. Okay, so the value of A is what? 1 0 1 0 here. Now the left shift, what it will perform? It will shift the numbers towards the left here. Okay, that means, so this 0 will be occupied with this position 0, and this one will be occupied with this position, and this 0 will be occupied by this position. What about this? So this will be discarded. This will be discarded. And what about this position? A 0 will be appended here. A 0 will be appended at this position here. This is the first shift. I am performing how many shifts? 2 shifts. Again I need to perform the left shift to this number here. Then this 0 will occupy this position. This 0 will occupy this position. So this one will occupy this position, and this 0 will be discarded, and 0 is appended at this right hand side. Appended. Getting my point? So this is the output I am getting. So what is the output I am getting? I am getting the output as 1 0 0 0. This is in binary. If I convert into the decimal, what I will get? 1 2 4 8. That is 8 is the output when I perform the left shift of a number by 2 times here. Got my point? Okay. Now you will understand the right shift here. Okay. So same number I will take and I will perform the right shift. So A is equal to 10, that is 1 0 1 0 here, right shift. That means this one will be occupied with this position 0, then 1, and this 0 will be discarded, and 0 will be appended at the leftmost bit here. This is the leftmost and this is the rightmost here. Okay, then this is the first shift, then second shift. So this 0 will be occupied here, 1, then 0, then this one will be discarded, and 0 will be appended at the leftmost. So what output I am getting here? 0 0 1 0, which is nothing but 2 here in a decimal representation. That is 2 I am getting as a output if I perform the right shift for the number that is 10. Okay.